Today we're going to be talking about equations and problem solving, and we're going to specifically concentrate on defining variables. So one of the first things that we're going to talk about is very similar to when we were solving equations or formulas that had more than one variable, the literal equations that had two or more variables, and we would solve those formulas in terms of one of the variables. So we're going to look at defining one variable in terms of another again. So let's say we've got the width of a rectangle. The width of a rectangle is 2 centimeters less than its length. 2 centimeters less than the length. Okay, that's information that we're going to need. And the perimeter of the rectangle is 16 centimeters. So the perimeter is equal to 16 centimeters. And they're asking for the length of the rectangle. What is the length? Now, they don't tell us what the width is, and they don't tell us what the length is. They only tell us perimeter. So in order to solve a two-variable problem, we would need two equations, but we don't have two equations. We only have enough information here for one equation. However, if we solve this in terms of just one variable, then we do have enough information to be able to solve it. Hold on, I just had to move that. Okay, so I'm going to draw my rectangle. This is one of my favorite things to do always, is to draw. This is my width and this is my length. Now, they tell me that the width is 2 centimeters less than the length. So that means my width is equal to the length minus 2. Okay? So if I, instead of using W, say I'm going to use L minus 2, length minus 2, now I only have one variable and I can solve my problem. First issue is I have to remember perimeter means the distance around the outside of my shape. So I know that if this is L minus 2, then this is L minus 2, and if this is L, then this is L. So that means I have two of those L's, two L's, plus I have two of these L minus 2's. Looks like distributive property is happening, L minus 2, and that means that the whole thing, the perimeter, is 16. So now, first step, I'm going to go ahead and I'm going to use my distributive property. So I'll have 2L plus 2L minus 4 equals 16. Combining these, I have 4L minus 4 equals 16. Adding 4 to both sides, the addition property of equality, I can solve it as long as I do the same thing to both sides. This crosses that off here, gives me 4L equal, and 16 plus 4 is 20. The division property of equality, 4 divided by 4 is 1, so I have my single L equals 5. Okay, oh, you can't even see that. Hold on. There it is. There's my L equals 5. And now what I'm going to do is I am going to put this L up here, and then 5 minus 2, this would be 3. And I'm actually going to go ahead and see if that equals. So this is 5, so that means that's 5. So I've got 10 plus, this is 3, so that means this is 3. So that's 6, and that equals 16. And sure enough, if my perimeter is 16, then my problem checks out. So what we're going to be looking for in problems like this will be to always try to figure out what one variable is in relation to another variable so that we can solve in one equation. So that's some of the problems you'll be doing today. The other is another very popular problem that we see very often, and this is consecutive integer problems. Consecutive integer problems. And if you were in front of me, I would be saying, what do we mean by consecutive? And somebody would be saying to me, oh, well, Mrs. Basic, consecutive, that means in order. So consecutive integers would be 3, 4, 5. Those are consecutive. I can also ask for consecutive odd integers. So if I say consecutive, and I'm going to get lazy here, consecutive odd integers, okay, now I might be looking at 3, 5, 7, okay? And so if I said to you, what about consecutive even integers? Okay, well, you're going to give me 2, 4, 6, something like that. So consecutive means one following the other. So these problems that we're going to be doing with consecutive integers will sound a lot like the sum of 3 consecutive integers is 48. So we know that we have 3 consecutive integers and the sum is 48. So I don't know what my integers are, so I'm going to start with my first integer. My first integer is x, okay? So I'm going to let x equal my first integer. Now if I were to say that the second integer was y and the third integer was z, so x plus y plus z equals 48, I would now have 3 different variables. I would need 3 equations. Obviously, I don't have 3 equations, so I only have one equation that I can see. So if I let x equal my first integer, let's go back up to my consecutive integers and see if I have 3 as x, how do I get to 4? Well, that should be pretty easy. We know that if we add 1 to 3, then we'll get to 4. So if I take my x and I add 1, that means I'm getting to my very next integer. So x plus 1 will equal my second integer. Okay? And if I also, so this is x plus 1 here, this is x here, okay? X plus 1, so 5. In order to get from 3 to 5, I have to add 2 to 3. So 5 becomes x plus 2, and that's where we find our third integer. X plus 2 equals the third integer. Okay? And quite simply from that point, all we're doing, we want the sum to be 48. So x, that's my first integer, plus my second integer, x plus 2, plus my third integer, x plus, oh my goodness, don't let me do it. Hold on. I should have my angel with me. Angel watching over my shoulder. Oh, here she is. This should be x plus 1, okay, my second integer, and x plus 2 is my third integer, and all of that equals 48. Now I'm going to combine my like terms. I have 1x, 2x, I have 3 x's, plus 1 plus 2 is 3. 3x plus 3 equals 48. Subtracting 3, subtraction property of equality gives me 3x equals 45. And dividing division property of equality, x is equal to 15. So that means if x is 15, oh, you can't see me. There we go. I'll bring the angel with us. Okay, so if x is 15, then my numbers should be 15, 16, and 17. Now what I'm going to do is I'm going to add those up. Okay, 5 plus 6 is 11, plus 7 is 18, carry the 1. 1, 2, 3, 4, 48, and that checks. So 15, 16, and 17 are my numbers. What I do need you to be prepared for is problems that are asking for the, if you've got consecutive odd integers, remember that when you're doing consecutive odd and even numbers, let's say we're just looking at 3, 5, and 7, okay? Well, okay, we're going to let x equal our first, okay? But in order to get to the second, we need to look at the fact that it's a little farther away, okay, than when we did our just plain consecutive integers. Here, we are 2 away, so x plus 2 is my second number. And then when I get to my third number, I'm looking at x plus 4. This also works when we are talking about our negatives, because our negative numbers will work the same way. So, so some of our problems could actually be working on the negative side. So that is really all we have for this section. It's hopefully a pretty quick and easy section for you. Okay, so till next time.